Hello, Stats class. I'm going to do a video recording for part of section 2.1 that talks about, we're going to talk about histograms and frequency polygons today. And so I have here my Canvas course open from one of my statistics classes. So if you go to modules, I've got, in addition to the workbook that you printed, the workbook pages, I do have some extra graphs that I'm going to look at and use today, a couple of pages. So I just want to show you where I'm getting that from. So I'm printing that from this quiz number 2 module. Here we have these saved lecture notes. And if you come down here, scroll down to kind of where we're at 2.2 now, see right here, 2.2 graphs. This is like basically like a generic blank set of PDFs that I've created in case like you can use that with today's lesson. And then also when you do your homework, if you want to do your homework on paper first and then create it on the computer, then this might be helpful because it's got a setup for class limits, frequency, you see midpoints, class boundaries. So, and then it's got some, see, generic graphs already. This is intended for like a histogram. Then you can make use of that for a frequency polygon. And then you're going to have a couple of ogives on your homework. Okay. And then a relative frequency graph, an ogive there. So this is where I'm getting these from. Okay. Also, let's see, your study guide for quiz 2. I updated this just a little bit here. So if you look at that, you want to decorate that. You can either use your own double-sided sheet from scratch and decorate that, or you can decorate this right on the side and then right on the back of that. But you are limited to one double-sided sheet for the quizzes. And so you'll have 7 problems and it'll be timed for 65 minutes. And this is what we'll be covering here. So I've already done a Zoom video for 2.1 and you have a homework set due for 2.1 if you follow your calendar, but number 1 and number 2 cover section 2.1. Okay. And so that material has been covered in your Zoom video. So be sure you look at that and then keep an eye on your homework. When you do your homework, make sure you pick a good example, either from the ebook or your homework, or from the Zoom video that you can put on there to help you when you take your quiz. But we're going to focus now on 2.2, which is basically question number 3. So if you see you'll have to on your quiz identify which of the provided visual displays is not a histogram. Then you'll have to identify the correct histogram for some information that will be given on the frequency distribution. And then you'll have to identify the distribution observed from a histogram. And so, so that's what we'll be covering, some of that today in this lesson here. Okay, so now let me share the document camera with you. So let me see. Oops. Share. There we go. There we go. Okay. All right. So these are just reminding you about our outcomes for the course. So they would be covering numbers 1 and number 2. So we'll be explaining the use of data collection and statistics as tools to teach reasonable conclusions, and then recognizing, examining, interpreting the basic principles of describing and presenting data. So that's kind of covered in what we're going to be doing today, 1 and 2. Okay, it's from our syllabus. Here's a copy of the study guide for the quiz. Okay. All right. And then let's take a look at your workbook pages. Oops. Oops, sorry. Let me get those. I thought I had those already. Let me get those out. Get your workbook pages. And that, let me see, that's going to start with, we're going to go over pages 34 through 37. Then I've got a couple of those graphs we're going to do by hand as well. So can you get those out? Let me go get that right quick. Sorry. Okay, sorry about that. I thought I had those out already, so I have to go grab them. All right. Yeah, so I had to, when, what I did for the workbook pages is I also had to download that file, put it on a flash drive, and I just took it into, like for example, I took mine into Office Depot and had them make those copies for me, and then it was considered bulk. There were enough pages. Of course, I was making several workbooks for my courses that I need, but I was able to get a bulk rate of, I think it was 9 cents as opposed to 15 cents a page because it was bulk. But yeah, I had to similarly do that too, make a PDF file on my flash drive, and then just pick that up curbside with Office Depot, and they made that workbook for me. Okay, but then still there's, in the workbook there's sometimes extra problems that I need to do. Then I have extra worksheets that are not in the workbook that I if that I put up for students to print on their printer. But this is too much for your, the whole workbook is too much for your printer to print all at once, so you'll burn out your printer. So if you're going to do that on your own, it's a lot of printing, but you have to do it either weekly so it doesn't get burned out. But I think you're just best off taking it somewhere and having that done if you haven't done that already. And then that way, if I have extra sheets, then you just print those from home on your home printer. Okay. And definitely, if you're taking an online class, you're definitely expected to have a printer for an online class. Where it gets a little difficult is if you're in a remote learning class. Nowadays, with the remote learning, which is a new feature, we're finding that it is helpful for students to have their own printer. Of course, if we were in a face-to-face class, then the instructors would provide the extra copies and things like that in a face-to-face class. But now we've got remote or the strictly online. Okay, so um, with this section 2.2, histograms, frequency polygons, and ogives. So it says statistical graphs can be used to describe the data set or to analyze it. Graphs are useful for getting the audience's attention, to discuss an issue, reinforce critical points, or summarize data, to discover a trend or a pattern in a situation over a period of time. The three most commonly used graphs in research are the histogram, the frequency polygon, and the cumulative frequency graph, which is the ogive. Now it does appear that the ogive is kind of being less used, it seems, in the research as opposed to the histograms and frequency polygons. But currently these are still listed as the top three, and so that's why we'll show you in your homework. Also, you'll be doing some of these, each of these three graphs. Okay, so first I talk about the procedure for these histograms, frequencies, and polygons, frequency polygon graphs, and then the ogive graphs. So they're asking you that you would draw and label the X and Y axis, that on the x-axis, you would label the class boundaries of the frequency distributions for the histogram and for the ogive. You would label the midpoints for the frequency polygon. Then for all these, you would need to plot the frequencies for each class and draw the vertical bars for the histogram. And then you would draw the line segments for the frequency polygons and for the ogive. And it says, remember that the lines for the frequency polygon, that they begin and they end on the x-axis, so they're anchored, whereas the lines for the ogive, they're only anchored at the front. They're only anchored at the x-axis. Okay, so to summarize that, I'm going to summarize that paragraph there. So I'm going to draw some pictures here. So if I start off, they were first talking about the histogram. So if I draw a histogram, sketch this here. Here's your x-axis, here's your y-axis. And they said that the x-axis consists of the class boundaries. Okay. Okay, and so I'm going to put CB for class boundaries. Okay, so remember our class boundaries, when you construct them, you're either subtracting or adding 0.5 or 0.05 or maybe even 0.005. Okay, so remember that whichever one you end up using, it's because it has to be, you use the one that ends up being 1 decimal place value beyond your class limits, or beyond your data. Because if your data is counting numbers, then your class limits would be if your data is in counting numbers, your class limits would be made using counting numbers. If your data is in tens place, then when you create your class limits would be reflective of the data also in the tens place. So that means when you create your class boundaries and you choose which one to subtract and add, you've got to use the one that's 1 decimal place beyond how your data is given or how your class limits are given. Okay, but the main thing here is that this is going to be for a histogram. On your x-axis, you're going to have class boundaries created here, whereas your y-axis will be your frequency. Okay, so remember we did the tallies in 2.1. We did the tallies and then you counted your total for your frequency. Each frequency had each class limit had a tally, and then you added up everything in the tally and you got a frequency. So if I just do a little sketch here, just a little sketch, kind of symmetric there, symmetric look there, bell shape for a histogram. That gives you an idea of that. Okay, now if I do a little sketch for the ogive, I'm going to put that right here. I'm also going to put an x-axis and a y-axis. You're still going to have your frequency along the y-axis, but notice here on the x how I'm going to change that to class. Oh no, I'm going to leave that, leave that as, leave that as class boundaries for X, okay? And this is called the ogive. It's not pronounced ogive, they pronounce it ogive, okay? And the ogives are anchored at the front only. Okay, so a picture like this would be something like this here. Something like that, okay? So that you use line segments. So ogives make use of line segments, okay? And importantly, they use class boundaries, okay? And then the third graph we're going to be using, let me do a sketch down here. We put the x-axis and the y-axis. So this is the frequency, but this is F for frequency, and this is called frequency polygon. And frequency polygons are, like they said that they're anchored on both ends. They're anchored on both ends. So here on your X, X is, notice how I'm not going to put this as class boundaries anymore. I'm going to put these as midpoints. And remember, we call those X of M midpoints. So when you make a midpoint, you either use the lower class limit plus the upper class limit, and you take the average of that and divide by 2, for example, or you take the lower class boundary plus the upper class boundary, you take the average of that and divide by 2. So remember how we started those? And a frequency polygon would look something like this. So I'm just sketching this out here. But you see how it is anchored at the beginning and at the end? So that's a frequency polygon. So on your homework set for 2.2 in Connect Map, this is what you'll be making, except you'll have to transfer your knowledge of what we're going to show you, and in your ebook and in this workbook, you just transfer over, then make use of it on the computer. So you'll be creating these ideas, but on the computer in your Connect Math. So you'll be making some histograms, some frequency polygons, and some ogives for the most part in this homework set. Okay, so before this Connect Math is like an enhanced version. Before that, the 2.2, it used to be one of the most tedious homework assignments, because I remember one time one of our tutors in Math Row, Mrs. Hurd, our go-to tutor in for statistics, I remember one time she went through the entire tutoring lab in Math Row and like wiped down all of the little mice, because to get that dust off those mice off the computers, right? So that it could have more like a increase the tolerance and the connections when you were making these graphs on the computer. But then some students who just had, a newer computer or updated mouse, some students, they didn't have any issues. They would just connect, pick up their segments and draw them and connect and not have any issues. But hopefully now they've created this. This is an enhanced version of Connect Math that we just adopted recently. I think the summer of 2020 is when it was adopted. So supposedly that should make this homework set a little more smoother. So we'll have to find out how the improvements is with the enhanced version. Okay. Um, let's see. So on the second page, let's look at your second page. Oh, I was going to read the bottom. There was something at the bottom that they said something about histograms at the bottom, that the histogram is a graph that displays the data by using contiguous vertical bars. And that's what they're talking about here. Okay. Um, unless the frequency of a class is 0. So of course, if the frequency is 0, then there is no raised bar. Of various heights to represent the frequencies of the classes. Histograms use class boundaries and frequencies of the classes. Okay. So here's an example that they have here on page 35 of your workbook. This is page 35 of your workbook. See that down here, 35 of your workbook. So it says that construct a histogram to represent the data for the record high temperatures for each of the 50 states. So apparently they have a related example there in your ebook you can look at. And so notice how they have the class limits here, and look how they already calculated all the class boundaries. They didn't let us participate, right, and calculate any of the class boundaries, okay? But they've got all those figured out there, okay? And then they've got the frequencies. So remember how these had to have been created. In order for these to be created, these have to be one decimal place value beyond how your data is, and they have to end in 5. So noting how these are counting numbers, they must have used a minus and a plus 0.5. If this is counting numbers, then this is tenths place. So that's 1 decimal place beyond. So if I verify that, this would be 100 minus 0.5, and then this would have been 104 plus 5. Yeah, and then that would check out. So if I just show you that on my calculator, that 100 minus 0.5, you can see is the 99.5, and then the 104.5 is 104.5. So you see how that matches that there. Okay, and then you would do that for all these problems here. For all these class limits here, you would figure that. Okay, so you would have to do that first. If you're trying to make a histogram, you would have to sit down and figure that first and do that. Okay, and then you would you label the X and Y axis. The X axis is always the horizontal axis. Okay, um, and then the y-axis is always the vertical axis. So you see how they've already got these numbered here. Here's your vertical axis. So these are the class boundaries, not the class limits. On the computer, they'll make some good distractors. When you take your quiz and when you do your homework, they'll say which one's the best histogram for this information that we have here, right? For this frequency distribution. So they'll put good distractors, like they'll down here on the x-axis, instead of class boundaries, they'll have an answer choice where they put the class limits. And that's wrong. When you make a histogram, you shouldn't be using the class limits. You're supposed to be making the class boundaries. So you do have to compute them, or at least the first two, and then you look at your choices and then identify the X's by the first two class boundaries that match your work, okay? But you can see here, these are your class boundaries from 99.5, see, to 104.5, then 104.5 to 109.5. And then you see the frequency, this frequency is 2 and then 8. So that's what we have here, 2 and then 8. And this one's 18. And then this one's 13, 7, 1, and 1. Okay. And so one of the questions there on your quiz, they were asking what would you say about the data's distribution? So I can ask that question here. What's this data distribution? Okay, so this data's distribution is, so we take a look at this. This is where you would like draw a silhouette. You would like draw and study a silhouette around your data, and then you always take a look at the peak. So you look at the bar that's got the highest amount of data, that's your peak, and then you start studying the data to your right and the data to your left. If you notice the data on your left hand side, we've got a total of 8 and 2, total of 10 data values. But if you look on the right hand side, you've got a collection of data 13 and 7 and 1 and 1. And if you add all that up, that gives you 22 data values. Okay, and then as far as they'll talk about a tell in your ebook, and the tell, this is considered more of a tell. This is shorter. See, these are down to 1, not by much. This is 2, but this would be considered more of your little tell here on this side. Okay, so this would be considered right skewed, positively skewed, because the data tapers off more heavily on the right hand side. So you see these bars, there's more bars on the right hand side, and also more data. Okay, so the data's distribution is right skewed. And this book, you know, at different times, it will sometimes have answer choices where it says, is it right skewed or left skewed? But then sometimes it will have answer choices and the choices are positively skewed or negatively skewed. So these are synonyms, and that's why I put both of them in, because it likes to vary the vocabulary on that. But this distribution is more right skewed, more positively skewed, and it's because the data tapers off more heavily on the right hand side. Okay. And other choices could be other scenarios, could be left skewed, which is also negatively skewed, or other scenarios could be symmetric, which is oftentimes called bell shaped. Okay. Okay, now since the next page 36 talks about a frequency polygon, before we do the frequency polygon, I do have a little exercise where those handouts come in handy. So we're going to just kind of do one by hand just to get a little extra practice. And before I do that, I was going to show you this page. This is on page 42 of your workbook. Okay, so if you haven't finished writing, you can pause the video and finish writing and then start it. Okay, but I'm going to look at page 42 here, and we were talking about, is it right skewed? So here's an example of right skewed. You see, here's your peak here, and you see you don't have a count of the data, but you look at your columns and see there are more columns on the right. The data tapers off more on the right as opposed to on the left. Okay, and this would be considered more of your tell. This is an example of left skew. The data tapers off more on the left-hand side. Okay, okay, and then oftentimes I'll talk about bell shape, symmetric shaped. Okay, so those are the most common ones that we'll see. When we do 2.3, you will talk about um, the I believe it's the reverse J shape. That's called oftentimes a Pareto. A Pareto. So let me put here. It's like kind of associated with a Pareto, but on the Pareto you have Paretos have like categories on the x-axis. Categories. So you won't have like numbers. Um, you'll have more categories. Um, so like motorcycles or um, certain calls made, more categories, as opposed to like uh, numbers, like class boundaries and things like that, numbers at the bottom. Okay, but we'll see more of that in 2.3. But that is a reverse J-shaped, oftentimes called a Pareto. Okay, and then there's other uh, shapes of distributions. Okay, they're not as common as the left skewed, right skewed, and bell shaped though. But those are things to familiarize yourself with. Okay, and then if we look at that one of those graphs, so these were like generic, so that if you wanted to do this for your homeworks, you could kind of have some kind of a skeleton to work with. So I have this. This should be first class, second class, third class, fourth class, fifth class, sixth class. Because you could have more classes. So if you do, then you would kind of run out of room. But this gives you an idea, something to work with. Maybe you could put lines in really small here if you had other classes. This is an example for 6 classes. And this is related to an NFL. See at the top it says histogram. Histogram. So this is related to, I'm getting this from from a problem in your ebook. I'm going to write this down, and we're going to make a histogram, and then we're going to make also a frequency polygon using this problem. So this has to do with NFL salaries, and it says that these salaries are in millions of dollars. And this is for a total of your data, 31 NFL teams for a specific season. And these are given already in a frequency distribution. And this is coming from, the source is the NFL.com is where that was coming from. Okay. And so, so we don't have the actual data, but we have this frequency distribution. So they gave us the class limits and they gave us the frequency. So that is 39.9 to 42.8, and the frequency is 2. 42.9 to 45.8, the frequency is also 2. 45.9 to 48.8, the frequency is 5. 48.9 to 51.8, frequency is 5. 51.9 to 54.8, frequency is 12. 54.9 to 57.8, and the frequency is 5. Okay. And so so this is given. Okay. And so you'll notice this looks good, right? This increases C by 1, see, as it should. A form of 1, right? A form of 1, okay? This actually increases by zero point 0.1, 42.8. 42.8 plus zero point 0.1. So it increases by a form of 1, and this has to have the same amount, same data, place values, right? Same place values, but that's correct. Okay, so those are corrected, made correctly. Okay, but when we're going to make this histogram down here at the bottom, we're going to make this histogram down right here, and you have to have your class boundaries here. And then I just, I just got this off of graph paper, a pad of graph paper, and I just chose to make it equal. You see this amount of boxes. I just chose to use 3. And I did the same thing here, so I have some consistency. And this is on the side is F here for your frequency. But if I were to count these as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You see I stopped there because remember the highest number at the top frequency, remember, was 12. Okay. And then I need my class boundaries down here. I need my class boundaries. So that's where I get this from. And I kind of did out of order. I guess I should have put class boundaries first and then midpoints, but that's fine. But we need to start with the class boundaries because we're doing the histogram first. We're not going to do the frequency polygon first. We're doing the histogram first. And class boundaries are for histograms and for ogives. Okay. And so when you, on your test, the first one you create for me on a test, you want to show me your work. So you want to tell me, how are you going to create this class boundary? You just don't want to pop the answer in here. You want to show me your work. So what I could do is do that here somewhere up nearby. So here I'm going to use a minus and a plus, and this has to be a decimal place beyond this. This is tens. So I need to use 0.05. That would be the right one to use from all my choices. Okay, 1 decimal place beyond. And then when I calculate that, that's going to be 39.9 minus 0.5, and then 42.8 plus, excuse me, minus 0.05, and then 42.8 plus 0.05. Okay, so then when I do that on my calculator here, I have 39.9 minus 0.05 and 42.8 plus 0.05. Okay, so that takes it to 39.85 to 42.85. So I'm just double checking that that's correct. Okay, and I'm going to squeeze that in here. Okay, so you would only have to show this detail here in yellow just for the first one. You don't have to do that for each one, but just show your teacher, communicate how you build those up. And then when you do the other ones, then like for example, then you could do then you don't have to show any more than that. Then you just do, okay, 42.9 minus 0.05 and then 45.8, see, plus 0.05. Okay, so that gives you 45.85, excuse me, 42.85, 42.85 to 45.85. Okay, and then if you wanted to, you definitely could continue in that manner, but then you're going to start noticing some patterns here. So you know how we said that this increased by one form of 1 unit plus 0.1, and that as it should. Notice how that doesn't happen here with the class boundaries. Notice how with the class boundaries these are identical. See that should happen. So that kind of helps you speed up this one. If you trust this work here, then you can either check your work, do it on the calculator, but you know that when you take a look at it, that these should match as they should with the class boundary. The other thing you can do to speed this up is you can also make use of the consistency of a class width. If I come over here and think about my class width, remember CW for class width. And remember how we do the class width. Remember how we have to subtract vertically? Remember these are lower class limits and these are upper class limits. So one way I can verify my class width is I could take 42.9 minus 39.9. So if I do it on my calculator, 42.9 minus 39.9, see how that's a class width of 3, right? So that's a class width of 3. Okay. Well, I want you to notice that this class width will also be shared the same for the class boundaries. So if I do here class width, if I do up here class width, if I do 42.85 minus 39.85, okay, 42.85 minus 39.85 is a class width, see, of 3. Okay, that's a pattern that should happen, but that will also help you create these faster because now you need this next one, and this next one's going to increase by 3. So if I check this, see, 39.85 plus 3, see, 42.85 plus 3, see how that does, then plus 3, plus 3, plus 3. See, and that might be faster than like if I do the check for the last one. If I do the check for the last one, it would be 54.9 going back to plus 0.05. See, gives me this. Oops. What happened? Let's see. 54 point, oh, I'm supposed to do subtraction. The first one is subtraction. So this is supposed to be 54.9 9 minus, see, minus and then plus. So minus on this side and plus on this side. So minus 0.05. Yeah, gives me, see, 54.85. Okay. So you've got a couple things to work with or check with and work if you want to speed that up. Usually on a test, what I'll do on a test is I'll do something like this. On a test, on your table, I will have some of these already completed so that on a test you have 110 minutes time, which is like an hour and 50 minutes to complete your test. So usually I will have some of these already done. Like I had the second class boundary done, second, third, and I had the fifth one done. So you don't usually have to do every single one. I'll have some of them already done for you, and that will save you some time also. But then here, if I want to continue with these, I just add 3. So 45.85 plus 3 is 48.85. 48.85 plus 3 is 51.85. 51.85 plus 3 is 54.85. And 54.85 plus 3 is 57.85. Okay, and again, if you wanted to spot check again, if I use this one here, 57.8, and then I'm going to add 0.05. So remember this, don't forget about that. And it should match to that. So you can always spot check those two that way, okay? But now we got our class boundaries done, okay? So then at the bottom, I'm going to start putting those down here. So the first one is 39.85. So I'm going to put that right here on this tick mark, start here. And then it goes to 42.85. Okay, and that has a class frequency of 2. So see, remember this was 3, so 2 is about right here. See, and that's class frequency of 2. And then we go 42.85 to 45.85. And that one also had a class frequency of 2. Okay, and then we go from the second one. So now this next one, 45.85 to 48.85. And that has a class frequency of 5. So this is 2, 3, 4, 5. And then after we have 48.85, then we have 48.85 to 51.85, which also is another class frequency of 5. And then after we have that, 48.85 to 51.85, then we have 51.85 to 54.85, and this is our peak at 12. And 12, let's see, goes up this way. And 12. Okay. And then the last class boundary is 54.85 to 57.85. And that has a class boundary of 5. Okay. All right. So then there's your histogram, and this was talking about salaries, and this was like in millions of dollars. And this was related to the NFL salaries, okay? And so, yeah, this is the NFL salaries was the title for that one, right? NFL salaries. And this was our peak here. And oftentimes they in your book they say how you can say something about like peaks or outliers. So 12 is like our peak here. So I said something like this for our peak. Oh, and this total here, this total was, let me see if I add all that up. Excuse me, if I add all that up, let me see what the total was. If I were to add all that up, I have it written here. It's probably faster for me just to look, add those up, right? But if I add those up, I think that should have been a total of 31. And it did say something about 31 NFL teams there, okay? But if I go back to saying a comment about the peak, I just said you could base it on the class limit or you could base it on the class boundary. But you could say like the fifth class boundary, or you can say the fifth class boundary, or you can say the fifth class limit. So this is the class boundary and then the class limit. So it's the fifth one. 1, 2, 3, 4, 5. So the fifth class limit or the fifth class boundary contains the peak, which was 12 NFL teams. Okay. Okay, and then the other thing I was going to do, if I look at the as far as talking about the data's distribution, if I go through and draw a silhouette on that, okay, what we look like, and if you have to decide what is the data's distribution, you can see on this problem that the data seems to taper off more on the left-hand side. If you look at your totals here, 5, 10, 11, 12, 13, 14, this side has like 14 data values, okay? Let's see how many this side has. This side, look, only has five data values. And then you also look at how it tapers off. See how this has 4 bars, 4 vertical bars? This one only has 1. Okay, so that's enough for you to say that the data's distribution is left skewed, or you can say that it's negatively skewed. And the reason why, because the data tapers off more on the left side. Okay. Okay, so that's the idea for the histogram. So then you kind of have to, you're gonna, on your homework, you should have some homework problems where you're gonna have to recreate this, but then with the effect of the Connect Math on the computer where you're using your mouse and things like that. So you might want to print another blank copy of these sheets to do it first on paper, and then like your homework on paper, and then you put that out on the computer. I do have it set up where you can print. I should have it set up and clicked where, and I have to do that every time. Click it where you can print your homework. So if you wanted to print your homework, it just takes up a lot of paper. But you could print that if you didn't want to be glued to a computer, and then go sit down and work on that. And then you go back and then put those in. So that's an idea. That's why I had those sheets there. That's why I left them kind of generic and blank. So you would put in your own class limits and your class boundaries. But you could also make your own table for that as well. Okay, and then we'll do one other example. Is we're going to do the frequency polygon. So let's see, with the frequency polygon, it says that the frequency polygon is a graph that displays the data by using lines that connect points plotted for the frequencies at the class midpoints. The frequencies are represented by the heights of the points. The class midpoints are represented on the horizontal axis. Yeah, so construct a frequency polygon to represent the data for the record high temperatures for each of the 50 states. So they've got your class limits, and see how we don't even get to participate here. See how they have all that filled out already? They have the class midpoints filled out, which is something you'll have to do when you do your homework. So remember how to find your XM, your midpoints. Remember here you would take 100 plus 104 and then divide that by 2. Okay, and you got to put in the parentheses. If you don't put the parentheses, you'll get it wrong. So it's parentheses 100 plus 104, close parentheses divided by 2. And you see how I get 102? Watch what happens when I take off the parentheses. Watch what happens when I do it without the parentheses. See how I don't get the same answer? So you want to be careful there, okay? And that's how you would compute these. Now, the other thing I can say about that, like as far as patterns go, and you might think it's a little bit faster. So like, oh, and also when you show your work, like on a test, you only have to show your teacher like the work for the first one. Okay. Then the other ones, like if you do the second one, you don't have to show this again. The second one, you just say 105 plus 109, close parentheses, divided by 2. And you see that gives you 107, okay? And you could actually do that for all the other ones, okay? Just show you that there. But the other thing is, if I, similarly how I did a pattern for the class boundaries, I can similarly do that. There's also a similar idea with the class widths and patterns here for the midpoints. If I do my class width and I do 105 minus 100, 105 minus 100 is just 5, okay? And if I do that on my class midpoints, CW here, if I do 107 minus 102, see how I get 5? These increase by 5. So in other words, another way to get this here is this could be solved by saying that this is also equal to 107 plus the class width, which is 5. So 107 plus 5 is 112. And then 112 plus 5 is 117. And then plus 5 is 122. Plus 5 is 127. Plus 5 is 132. And then if you wanted to double check that, you could double check the last one. Parentheses 130 plus 134, close parenthesis divided by 2. See, so you could, if you think that's faster or you want to just double check, doesn't hurt to double check. But that's your class width there. Okay, so then they're saying on your steps, you would find the midpoints. Okay, and they're reminding you how to find that. You add the lower and the upper. So remember, these are lower class limits, upper class limits. You take the average, divide by 2. You would draw your X and Y axis, label the X-axis with the midpoints of each class, and then use a suitable scale on the Y-axis for your frequencies. Use the midpoints for the X values and the frequencies as the Y values. Plot the points, connect adjacent points with line segments. Draw a line back to the X-axis at the beginning and at the end. So this is important of the graph because it needs to be anchored. Frequency polygons are anchored at the same distance that the previous and next midpoints would be located. Yeah, so I'm not sure why they put this again. I don't think they needed to put this data again. It's the same data that's there. But if you look at the next page, they have a picture of that here. So you'll notice here, notice that these are the class midpoints. So you see here 102, see, 107, 112, 117. See, these are your class midpoints. So they've got these listed there. And then when they when they anchor them, remember we said that the class width, so let me go back to that page there. Let's see. Yeah. Remember we said on the class width, if I find the class width, and remember I was using the class limits for that, for example. If I do, I said 105 minus 100. Remember we said the class width was 5. Well, these are all 5 units apart, right? Well, to anchor them, what I can do here, this value here, this value is going to equal 97. And why? Because you're going to do 102 minus 5, which is the class width. So that would be this number here. When they anchor it, this would be 97, 0. This one here is 102. And then let's see, the 102 frequency is 2. This one is 107, frequency is 8. Okay. This top one, that looks like your peak, right? 112. So that's 112 and then 18. Okay, so you see where those are coming from. But then when you start coming down this way, you see how you have to anchor it? This 132 is the last, this is the last midpoint right here. Okay, whereas this one was the first midpoint. 102 was the first midpoint. Well, this one's the last midpoint, 132, and look at the frequency is just 1. So you have to anchor it. So where do I anchor that, right? So this number is going to equal 137. And why? Because you take this midpoint 132 plus the class width, which is 5. So here you got to add. We're over here we were subtracting previous. Here afterwards you add, and 132 plus 5 is 137. So this is the 137, 0. Okay. So the frequency polygons, see, they're anchored at the beginning and at the end. Okay. So we're going to do that. This is the last thing today in the video I'm going to do. Next time I'll go into a video on the next part, which is the Ogive. But the next thing I'm going to do is do that, go back to that NFL problem, and see where that was at. Go back to this NFL problem here. And see how I have this column here for midpoints? So we're going to go back and use this to find the midpoints for that NFL problem. And then on those copies, those extra copies I was showing you at the beginning from your Canvas course, see how I have this generic for this is a chopped off, for a frequency polygon. See, it's kind of generic here for a frequency polygon. See how I have class midpoint, and see how I'm anchoring. So of course, I don't know how many segments you would have. And I'm going to actually take this one off because I think I was short. I needed some extra space. But the idea is you have to, I just want to remind you, anchor at the beginning and at the end. So this one here is for your first midpoint, because we have to use this one. This one's not for the first midpoint. This is to anchor it. Okay, and I just did increments of 3. So if you have your own graph paper, and you can do increments of 3 or 4, however you need. I just did increments of 3, and then I was just consistent. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15. I didn't need much more than that, but this NFL data, remember the NFL data, the frequency, anyhow, the highest was 12 anyway. Okay, so when I go to my data here, my midpoints, remember you only, on the test, you only have to show the work for the first one here. So here on my midpoint, I'm going to say this is 39.9 plus 52.8 and parentheses divided by 2. So that's required for the first one. So you take your lower class limit, which is parentheses 39.9 plus 42.8, close parentheses divided by 2, and see that gives you 41.35. Okay, but then when you do the second one, you don't have to show this again. You just demonstrate it for the first one. When you do the second one, you could do parentheses 42.9 plus 45.8, close parentheses, divided by 2. You see how that gives you 44.35? See, but then that's enough to talk about this pattern. Remember, these also similarly share a pattern. So remember how we talked about the class width? Remember how I showed this here, that it was 3 for this NFL problem when I did 42.9 minus 39.9? Well, look what happens here. See, if I do that class width here, if I do 44.35, take away 41.35, see, that's a pattern here. See how you get 3? So these are going to increase by 3. So you see, if I do 41.35 plus 3, see, plus 3, see, 47.35 plus 3 plus 3. It will vary for problem to problem, right? Depending on your class width from your class limits, it will vary. But this one's plus 3 on that one. So you see that's a little bit faster. 56 here. And then if you just wanted to double check the last one, you could. You want to double check the last one, parentheses 54.9 plus 57.8, close parentheses divided by 2. See how you do get that. See that? Okay. So then now you go to your graph here, and remember the first midpoint. The first midpoint was 41.35. So you put that down here, and remember you have to anchor it. So actually, that's why you might want to do it on paper first and then on the computer, because when you do it on the computer, this is not the first thing you're going to put on the computer. So you have to start off anchoring it. So that's why you might want to do it on paper first and think it out. But when you anchor it, you need to use the class width. So this number here is going to be calculated by doing 41.35 minus 3. Because remember, that was the class width. So 41.35 minus 3 is 38.35. So that's this number here. And that's anchored at 0. That's anchored at 0. So this is 38.35. That anchors there. But then this midpoint, 41.35, that has a frequency of 2. So 1, 2. So this is 41.35, 2. And then on paper, I have my ruler here. So remember they said line segments, but on the computer, when you do this on the computer, you're using your mouse and you're picking up some kind of a line segment and you're drawing that there. Okay, then we have the next midpoint is 44.35, and that frequency was also 2. So 44.35 with a frequency of 2. I just go straight across. And then the next midpoint is 47.35. And that frequency was 5. We have a couple of 5s coming up. So 2, 3, 4, 5. And when you're doing this on paper, I like to label that. But on the computer, it's not going to require you to label the points. It's just going to want you to pick up your mouse and drag it here. Okay, and then this next one was 50, the midpoint 50.35, and that one was also 5. So you see 50.35 and 5. And now we have a 12 and then another 5 coming up. So for the frequency of 12, the midpoint is 53.35. And then way up here, 12 is somewhere way up here. And you can always, pause your video. If I'm going a little too fast, you can pause your video and then start it. But I'm just doing that, connecting. And then the last midpoint is 56.35 and then 5. But remember, we're going to have to anchor it. And it was 5. So that's the last midpoint, but we're not done. We're going to have to anchor it. And remember, you're going to be doing this on the computer. So you might want to do it on paper first. You print out these sheets and do your problem on paper first, and then you go to a computer and do that. And you just have to be, like if I were to do that on the computer, that would be wrong. It's off. You need to make sure these are in line. Okay, because it probably would dock me for that, mark it wrong. Has to be accurate. And then the last, you have to anchor it. So now if I do 1, 2, 3 right here, this is going to be figured by 56.35 plus 3. Because remember that's the class width. So remember over here you subtract when you do previous, but over here after you add 3, and that gives you 59.35. So this is 59.35 comma 0. And then you connect that. Okay. Okay, and then that concludes my video for today. So I just wanted to show you from this 2.1, I mean, this is 2.2 section, I wanted to show you histogram and the frequency polygon, so you can kind of start working on your homework for 2.2. If you have already done 2.1, this is to start you working on your 2.2. So you want to read your ebook, and then this is the idea to help you with that. And then at some point soon I'll be putting up another video to help you with the second part of that lesson. Okay. All right. Okay. So good luck with that. Remember Math Row. If you have any questions, remember we have the tutors in Math Row. So in your Canvas course, there's a module about Math Row. You click on that link. Make sure you see all the tutors who are employed. They're all working from home, and all they have to do, their only duty is to tutor the students. And so not like the teachers, they have to make tests and grade and lecture. All the tutors have to do is just answer your questions. They're from like 8 in the morning to 7 o'clock at night. So you just need to zoom in with them, find a tutor or your favorite tutor, make sure they have the 1342, the statistics listed by them. And then you can try different tutors, and have your favorites, but you should definitely try all of them out. Again, the go-to person is Trudy, Mrs. Hurd, Gertrude, because she's the one who's actually sat in our faculty's classes and she got paid for doing that. But otherwise, if she's preoccupied or she's not in at the time that you need her, then you can look at some of the other stats tutors, okay? But this video and that will help you together with your Connect math, okay? All right, take care. And let's see. And I was just thinking on your title, this is your frequency polygon. So again, I should just put your label. This was in salaries, right? Millions of dollars. And this is the NFL salary, still NFL salaries. So it has some kind of a title on it, which is similar to the histogram. All right.